So students, uh, today we will do the topic LTI system, that is the linear time invariant system. Okay. So this topic we have covered in the signal and system also. So I will give you a brief about this LTI system, and we will discuss the numerical of the LTI system also in this lecture. So we will starting with the LTI system. First of all, LTI system is the linear time invariant system. So it is the linear time invariant system. So LTI system is basically obey the two properties. Okay. So first property is the LTI system must be a linear system, means our LTI system must obey the property of the linearity. It must be a linear system. Second, it obey the property of the time invariant system, means it obey the property of time invariant, means input output characteristics changes with time. That system is called the time invariant system. Second, first one we are having a linear system, that is the it obey the principle of the linearity. Okay. So we are having a LTI system which obey these two properties. First one is the linearity property, second one is the time invariant property. So a discrete time LTI system, or we can say that the convolution sum for discrete time LTI system. So we are having a like a convolution sum for discrete time LTI system, means we are having a convolution sum of discrete time system. First, like in the signal and system, we have done the topic of the LTI system. Then we have done the derive the equation of the discrete time convolution sum of discrete time LTI system. So we will denoted this as the yn is equal to summation n is equal to minus infinity to infinity xk h n minus k. Okay. So we are having this equation xn convolution of hn, that is the yn is equal to summation n is equal to minus infinity summation n is equal to minus infinity to infinity xk hn minus k. So this is the expression for the convolution sum of discrete time LTI system. So we will in this lecture, first of all, we will discuss the properties of this LTI system. This is our LTI system, basically convolution sum of discrete time LTI system. And in this chapter, like in our subject is digital signal processing, we will discuss the convolution sum that is in the discrete time. Okay. But in the signal and system, in your previous semester, we have discussed the LTI system, that is the continuous time LTI system. But in this our subject is digital signal processing, we will discuss the convolution sum of discrete time LTI system, means we will focus on the discrete time LTI system. We will not discuss the continuous time LTI system in our syllabus. The part that is included, that is only the discrete time LTI system. So we are having a xn convolution hn, that is the yn is the output. It is given by summation n is equal to minus infinity to infinity xk hn minus k. So this is the convolution. So from the LTI system, maximum examiner will ask the properties of LTI system. Okay. Next, they will ask the like a numerical on LTI system, numerical of LTI system. Then they will ask the like a homogeneous solution of homogeneous solution of discrete time LTI system equation. Then they will ask the particular solution of discrete time LTI system. So these four things are very important from this LTI system point of view. Okay, so we will discuss the properties of LTI system. This numerical of LTI system we will discuss in the next lecture. That is the convolution numerical. Okay, this is the basically convolution based numerical. There are the four methods to solve this numerical of LTI system. Then we will find out the homogeneous solution. Then we will find out the particular solution of this system. Okay, so one by one we will first of all we will discuss the properties of LTI system, then numerical of LTI system, then homogeneous solution, then particular solution. So first we will start the properties of LTI system. So first property of LTI system, that is the commutative property. First property we are having like a, that is the commutative property. So this is the first property of the LTI system, that is the commutative property. So what is the commutative property of the LTI system? It is saying that when we are having a yt is equal to, or we can say that the yn is equal to xn convolution of h, means if we are having a yn, this is equal to xn convolution of hn, then according to the commutative property we can say that yn is equal to the hn convolution of xn, means according to commutative property these two are equal, means xn convolution of hn is equal to hn convolution of xn. So these two are equal. Okay, xn convolution hn is equal to hn convolution of xn. So it is the equals. This is the first property of the like of a LTI system. Then second property we are having a distributive property. Second property is called the distributive property. That is the distributive property. This property states that the like if we are having a I will explain you this property through the diagram. If we are having a xt as the input and we will apply this input, or it is in the continuous time, I am explaining you in the continuous time. If we are having a xt, or it is a continuous time signal, we will write down here as the xn also. In a discrete time it is similar. Okay, so I will explain you in the discrete time, because in the digital signal processing we are talking about the discrete time signal. So xn we are having, then we are having this h1 and then here we are having a h2 and this is the response of the system. Okay, so then we are having this output, we will apply here one adder. Okay, so what is the output of the adder? That is the we are having a like a, we will apply first xn to this input. So it is the yn is equal to y1 n plus y2 n. So what is the y1n and y2n in this equation? I will writing here. So y1n and y2n are the, we will write down the y1n is equal to xn convolution h1n and y2n is equal to xn convolution h2n. So we will write down the y, and this total value is equal to xn convolution h1, and this is the first one, plus xn convolution h2n. So this is the output of this system. Now, what is the distributive property is saying that? Distributive property is saying that if we are having a like a parallel combination, here we are having a parallel combination, means xn is the input, h1n is the first system, h2n is the second system, means we are having a two system, h1 and h2n. These two systems are connected in the parallel. So distributive property say that a parallel combination of LTI system is replaced by a single LTI system whose impulse response is the sum of individual impulse response. Means according to this distributive property, if we are having this parallel combination, it must be replaced by a single system. Means this parallel system will replaced by the single system. So which is the single system here? We are giving the xn input. Okay. Now we are giving this input to the single system. Here we are having a parallel system. Now this single input is given to the single system, and this single system is having the impulse response, that is the impulse response of these two systems. Means by using this distributive property, this parallel system is replaced by the single system. Okay, so xn input is given to h1n and h2n, and its output is the yn. Okay, so these two systems are equal according to the distributive properties. These two systems are equal. So what is the output of this single system? According to this distributive property, we are having a yn is equal to x n convolution of h1n plus h2n. So according to distributive properties, this equation and this equation, this is our first equation, this is our second equation. These two equations are equal according to distributive property. Distributive property saying that we can replace this parallel system with this single system if we are adding, if the impulse response, important thing is this one, the impulse response of these two parallel system is equal to addition of this single response. Means we are giving this input to this single system, and the impulse response h1n plus h2n is given here, and the output is the yn. Okay, so this is the addition of the impulse response. Okay, so this is the distributive second property of the LTI system. First one is the commutative property, second one is the distributive property. According to this distributive property, the parallel system is replaced by the single system, and the impulse response of this single system is the addition of impulse response of the two system. So this is the second property over, that is the distributive property. Now moving toward the third property, this property is called the we are having a associative property. Okay, the third property, that is the important property, that is the associative property. Third property is the associative property of LTI system. So according to the associative property, we are having yn is equal to xn convolution h1 and convolution h2 n. So this is the, if we are having a yn equal to xn convolution of h1n and a convolution of h2n. Okay, so this equation is equal to the, we can write down yn is equal to xn convolution h1 and convolution h2n. So this is our second equation. So according to this associative property, we can say that if we are having yn is equal to xn convolution h1n and then its convolution h2n, this is equal to the equation number second. Okay, so what is the meaning? According to this property, the impulse response of the cascade of two LTI system is the convolution of their individual impulse response. So means according to the equation first, if we are having a like a xn input here, this input I have given to the first h1 and then its input is given to the h2 and okay, means that these two systems are cascade. Okay, first input is given to the h1 and then it is given to the h2 and okay, this is the, then we are having a yn output. Okay, so if we are having a like another system like xn is equal to h1 and convolution h2n, then its output is the yn. Means according to, listen student, according to this associative property, what its meaning? Now this is the, now first listen this series equation number 2. According to the equation number 2, we are having xn. This is the first, we will take the convolution with the h1n, means we will apply the one system here. Okay, then the output of this system is then convolution with the second system, means the output of this one is the x1 and this is the output of this system. Output of this one is the x1 and convolution with h1 and then it is the again convolution with the h2n. Okay, so it is the cascade of two system, means the input is given to first system, then input is given to the second system. Here we are having a cascade of two system. Now these two systems cascade of, this is the cascade system. We cascade system means in which two systems are connected in series. Then this cascade system is replaced by a single system. This is the, we are having a single system. So what is the single system? We will take the one system, instead of using these two systems, we are using the single system. So in this single system, we are do the convolution of h1n and the convolution of h2n, means this single system having the impulse response. This single system is having the impulse response is the convolution of these two. Impulse response of one this single system is the h1 and convolution h2n. Okay, so this is the impulse response of this, means using associative property we are replacing these two systems by a single system, but the impulse response of this single system is the cast is the convolution of h1n and the convolution of h2n. Means we are replacing the two system by a single system, but in the single system impulse response जो होगा हमारा, that must be a convolution of first impulse response and the second impulse response. Then these two equations are equal according to the associative property. So this is the third property, associative property. We have learned the three properties. First one commutative, second one distributive, third one is the associative property. Okay, now moving toward the fourth property. Mostly the examiner asked this fourth one property in the question, that is the Causality of LTI system. Causality of LTI system. So this is the fourth property of the LTI system, that is the causality of LTI system. So basically in the last lecture we have discussed the causal system and the non-causal system. I will explain you that a causal system is the system. Generally, what is the causal system? Then we will discuss the causality in the LTI system. First of all, we will discuss the causal in the normal system. This is the in the normal system. Means normal. What is the definition of the causal? It is depend whose output is depend upon the present and the past value of the input. Means in this system output is upon depend upon present as well as the past input. Okay, so this is the causal system we discussed in this last lecture. Means output is depending upon the present and the past input. That system is called the causal system. Okay, now we will discuss the causality of LTI system. Means how our LTI system is causal. Okay, so to discuss this causality of this is happening in the normal system. हमारा normal system causal कब होगा? When the output is depending upon the present and the past input. Means yn is the depending upon either xn or it is depending upon xn minus k. This is the present input, this is the past input, delay input we can say. So this is the definition of causal in the normal system. So now what we have to do? We have to learn the causality of the LTI system. Okay. So LTI system must be causal. We can say that the LTI system is causal. Okay. When we are saying that our LTI system is causal, हमारा causal कब होगा? ठीक है. When impulse response is zero for negative values of t, then we can say that our LTI system is causal. हमारा LTI system causal कब होगा? When Hn is equal to zero. Impulse response is equal to zero. ये क्या है? Impulse response is equal to zero. ये कब होगा? For negative values of t. For t, or you can say that for n lesser than 0. In the discrete time system, we can say that LTI system is causal if Hn over impulse response is 0 for negative values of t. Okay, so what is the equation of convolution for the causality system? So we have written yn is equal to x n convolution h n, that is equal to the summation n is equal to 0 to infinity x n h n minus k. So we can say that this is the equation of causality for the LTI system. In some books, it is written like this one. They have written like h n x n minus k, because according to the commutative property, we are having x n convolution h n is equal to h n convolution x n. Okay, so we have written h n x n minus k. This is the condition of causality for the LTI system. Okay, means normally ask the question, what is the causality condition of the LTI system? You simply say that LTI system is causal if impulse response is equal to 0 for negative values of n. Okay, means impulse response a value of hn is 0 for the negative values of n, Then our system is the causal system. Causal LTI system is our causal LTI system. Okay. So moving toward the last property, that is the stability of LTI system. Stability of LTI system. So if I am talking about the normal system, means we can say that our system is stable when it is follow the BIBO criteria. Okay, normal system is stable if it is follow this BIBO criteria. What is this BIBO criteria? That is the bounded input and the bounded output. Okay, then we can say that our system is the stable system. Then we can say that our system is the stable system. Bounded input means we are giving the finite inputs. Bounded output means our output is also a finite. Means if this is the system, I am giving some input xn. This is the finite, and output is also a finite value. Then this system is the stable system. Okay, means that this is also a finite and this is also a finite value. Then this system is the stable system. Okay, but if I am giving the finite input to the system and I am getting the infinite output as the system, then this system will become the unstable system. This will become the unstable system, means they are not the bounded input and bounded output. When I am giving the finite output, this is the bounded input. When I am getting this infinite output, this will become the unbounded output. Okay, unbounded means it is not a bounded, it is getting the infinite value, so it is the unbounded output. So that system must be a unstable system. So we are having a two type of system, stable system and the unstable system. Now what we have to learn, stability of LTI system. What is the condition of the LTI system when it is will become a stable? कि हमारा LTI system कब stable होगा? ठीक है? We will study this property. This is for the normal system. BIBO criteria is for the normal system. Okay. So we have to study the stability of the LTI system. Means when our LTI system is stable or unstable. Okay, so we will discuss that. Like we are having a output like a yn is equal to xn convolution hn. Okay, so this is the equation of convolution in discrete time system. That is the summation n is equal to minus infinity to infinity x n h n minus k. So this is the equation of convolution of LTI system. So we will change this equation as h n convolution x n. This is equal to summation n is equal to minus infinity to infinity h n x n minus k. Okay, so this is according to the commutative property. Okay, we have applied the commutative property to the equation number second. Now This is the step first. This is the step second. Third step, if our input is bounded, okay, means we are having xn as the bounded input, okay, means we are having xn as the bounded input, okay. Then that means if our input is bounded, its delay version is also bounded, okay. Means if we are giving that our input is bounded, then its output is a delayed version, or its delayed version is also getting the bounded, okay. So from this equation means we will write down x n minus k. It is our delay version. It is the, if it is, we are saying that it is the bounded input, okay, means its value is lesser than m. M is the any finite number, okay. So it is the finite number, okay, means input means bounded, then its value must be less than m. M is the any finite number. We will put this value here, okay. We are putting y n is equal to summation n is equal to minus infinity to infinity h and m. So students, see this, this is the m, this is the finite value, okay, and we are having a hn here, okay. So we are left only with this part. This is the m is the finite number, and we have to find out the value of n is equal to minus infinity to infinity hn, okay. Means if we will solve this value summation n is equal to minus infinity to infinity hn, if we will solve this value, and this value will become a finite value, okay. If we are solving this summation value and it is answer must be a finite, then we can say that our output must be a bounded. Means we, हमने क्या चेक करना है कि हमने ये चेक करना है कि हमने इनपुट तो बाउंडेड दे दी है, ठीक है, we have given the input as the bounded, but we have to check whether my output is the bounded or not. If my output is bounded, okay, then it satisfied the criteria of BIBO. Then we can say that our LTI system is also a stable. Means our LTI system equation is yn is equal to n is equal to minus infinity to infinity summation hn xn minus k. Means our input is bounded, that we have given, okay, that we will assume our input is bounded. Now we have to check whether my output is the bounded or not. So our output must be bounded if it must be a finite value. Bounded means it must be, output must be a finite value. If my this value summation n is equal to minus infinity to infinity hn, this must be a finite value, okay, then my LTI system will be a stable, okay. So the condition is, for the LTI system to be stable, the condition is the impulse response must be a absolutely summable, okay, means this impulse response must be a finite value, then our LTI system must be a stable, okay. So we can say that for the stability of the LTI system, or we can say that our LTI system must be stable. For here I am writing for LTI system, okay, stability is depending upon if condition is n is equal to minus infinity to infinity h and values must be lesser than, its value must be lesser than infinity, means it must be a some finite value, okay. Then my LTI system must be a stable. Means if this value, to solve this value, I am getting some finite value, then our LTI system must be a stable. Okay, means इसको ऐसे भी लिख सकते हैं, if my impulse response, in some books it is written as if response impulse response is absolutely summable. If impulse response is absolutely summable, then our LTI system is the stable. Okay. Then we can say that our LTI system is the stable system. So this is the stability of LTI system. Now, student, now we will discuss the next topic, that is the linear constant coefficient difference equation. This is the very important topic from the paper point of view. So next topic we are having a linear constant coefficient, linear constant coefficient difference equation. So we are having a topic, linear constant coefficient difference equation. This is the very important topic of this LTI system. So mostly the examiner asks about this linear constant coefficient difference equation numerical, how to solve the difference equation of linear constant coefficient, and how to find out the solution of this linear constant coefficient difference equation. So we are having the like output of the discrete time system. We can say that the output of discrete time system, that is the convolution sum that we have done in the previous topic. Output of the discrete time system is basically the convolution sum, and we will denote that output is equal to yn is equal to summation n is equal to minus infinity to infinity x n h n minus k. So this is the output of the discrete time system, that is the convolution sum. And we will, in this part we will study the difference equation which are used to implement the discrete time system or the digital filter. From this equation, this output of discrete time system, we will derive the difference equation. And where we are using this difference equation, it is used to design the filters, digital filter. Basically we are using this difference equation in designing of the digital filter. We will design the FIR filter, finite impulse response filter, infinite impulse response filter, with the help of these difference equations. So it play a very important role in the digital signal processing. With the help of these difference equation, we will design the digital filter and we can implement the discrete time system also. Okay, so from this equation, like this is the general equation of the discrete time system. Now we will derive this equation for the causal system as well as for the non-causal system. So if I am talking about the causal system, means Hn is equal to 0 for negative values of n, causal LTI system. So I am writing this equation as the yn is equal to summation n is equal to 0 to infinity x n h n minus k. So this is the equation for the causal LTI system. Okay. Similarly, for the non-causal LTI system, this is the equation. Means in this is the basic equation for the non-causal LTI system. This is for the causal The above equation is for the non-causal LTI system. So we are having the equation for the causal system and the as well as the non-causal system. So HN, when we are defining the causal system, when we are defining the non-causal system, what is the important parameter? This HN. Okay, impulse response. Basically, we will see the impulse response. When we have derived the causality property of the LTI system, means we will find out the value that Hn is the zero for negative values of n. Okay, so yn is equal to n is equal to 0 to infinity xn hn minus k. Okay, so this is the causality condition of LTI system. Okay, so basic meaning is that in this equation, this is the convolution equation. In this equation, Hn over impulse response play a very important role. So depending upon the Hn, we can say that the length of Hn is also called length of impulse response. We can say that Hn is the so we are having the equation like yn is equal to summation n is equal to 0 to infinity x n h n minus k. Okay, this is the equation for the causal system. H n play a very important role. This is called the impulse response. Okay, so Hn is the length of impulse response. We can say that it is also called the length of the impulse response. Hn is also called the length of the impulse response. So according to this length of the impulse response, we can define the system in two categories. That is the FIR system, okay, finite impulse response system. That is called the finite impulse response system. Second one we are that is called the IIR system. That is the infinite impulse response system. So depending upon this length of this impulse response, we are having two type of system. This is the two type of systems. Okay, depending upon this length, we are having depending upon this Hn, we are having two type of impulse response. First one is the finite impulse response system. Second one is the infinite impulse response system. So these are the very important. So what is the finite impulse response system? What is the infinite impulse response system? We are having a separate equations for this finite impulse response system and the infinite impulse response system. And the difference upon these two systems is only matter in terms of the length of the impulse response. Means in these two systems, either in the finite impulse response or either in the infinite impulse response, the main thing is the length of the impulse response. In these two systems, only the difference is the length of the impulse response. So first we will talk about the FIR system. Okay. Now FIR system equation is the Yn is equal to summation n is equal to minus m to m. Here we are taking the range from the minus m to m. Means it is the finite range because this system is our finite impulse response system. Okay, so it is the finite impulse response system. So finite means we are taking this finite sample. N is equal to minus m to m x n h n minus k. This is the first equation. Now here we are taking the range of n is from the minus m to m. Okay, that means this is the non-causal. This equation is the non-causal FIR system. This is the non-causal finite impulse response system. Then we will write down the, if I am writing yn is equal to summation n is equal to 0 to m. Now the range I am taking n is equal to 0 to m x n h n minus k. This is the second equation. This equation is for the causal system. Okay, because here we are not taking the negative values of n. This equation is for the causal LTI system. Okay, the above one is for the non-causal LTI system. Okay, so if I am writing this equation like this one, I am writing this equation h n x n minus k. So this is also equal according to the commutative property. This equation is also equal. So we can write down it as the x h n or x n minus k. These two are equal equations. Okay, according to the commutative property. This is the equation for the non-causal finite impulse response system. This is for the causal FIR system. What is the non-causal? The range is from the minus m to m. Okay, but in the causal system range is from the n is equal to 0 to m. Here we are having a range 0 starting from 0 to m in the case of causal, because we are having for the causal LTI system h n is the 0 for negative values of n. Okay, so we are not taking in the causal system, we are not taking the negative values. Okay, this is the causal LTI system, this is for the non-causal. But these two equations, this is this equation and this equation, this is come under the finite impulse response, because range of is the finite, m is equal to minus n to m. Here range is the n is equal to 0 to m. So these two are come under the categories of finite impulse response system. Next we are having a system that is the infinite impulse response system. So depending upon the length, okay, infinite impulse response system. So what is happening in the infinite impulse response system? Again, we will discuss the now first I will tell you what is the infinite impulse response system. Infinite means the number of samples of the impulse response. This number of samples of the impulse response Hn, it is the infinite. So in this case, we will take the equation yn is equal to n is equal to minus infinity to infinity. Okay, because here the number of samples of Hn is the infinite, means n is range from the minus infinity to infinity. Okay, so range in this case is the infinite. Next, if but this is the equation for the non-causal. Okay, this is the equation for the non-causal. Next, we are writing the equation for the causal system. Okay, causal IIR system. In this case, the range is from the 0 to infinity. Okay, Hn xn minus k, because in causal system Hn is 0 for negative values of n. That is the uh, condition of causality in the LTI system. So it must be a zeros for negative values of n. Okay, so this is the causal LTI system, and the above one is the non-causal LTI system, IIR system. Okay, infinite impulse response system. Now the basic, I think it is clear to everyone. Finite impulse response system means we are having a finite number of samples. Infinite impulse response system means we are having a infinite number of samples. Okay, so we are having a finite impulse response and the infinite impulse response. And in the finite impulse response, we are having a two categories. First one is the causal finite impulse response system and the non-causal finite impulse response system. And similarly, in the infinite impulse response system, we are having a two categories. First one, we have taken the non-causal infinite impulse response system, and second one, we are having a causal infinite impulse response system. So this is the we will discuss finite impulse response system or infinite impulse response system. So instead of this finite impulse response system or the infinite impulse response system, we are having another kind of system that is called the recursive system and the non-recursive system. Okay, we are having a two kind of system. First one is the recursive system, and the second one we are having a non-recursive system. Okay, so first of all we will talking about the non-recursive system. Non-recursive, the major difference between the recursive and non-recursive system is that in these two systems the most important parameter is the feedback. Okay, in the recursive system we are using the feedback system. In non-recursive system we are not using the feedback system. This is the major difference between these two. So first of all we are talking about the non-recursive system. Non-recursive system means no feedback. Okay, in this system no feedback is there. Okay, and in the recursive system we are using the feedback system. Okay, so in the non-recursive system do not require the past output sample to calculate the present output. Okay, so we are having the equation like a non-recursive system. Yn is equal to summation k is equal to 0 to m h k x n minus k. So this is the equation of the non-recursive system. Means output is not depending upon the past output system. Okay, means there is no feedback system in the non-recursive system. So in the case of recursive system, some part of the output is connected to the input. Okay, that is called the recursive system. Okay, so coming toward the recursive system, this system is having a feedback system. So in this case the output is depending upon the output is depending upon the present input as well as on the past input as well as on the past input and the previous output. Means this is depending upon the feedback. Okay, previous output means it is taking some feedback from the output to the input system. If I am drawing the circuit diagram of this recursive system, it is like we are doing the x and input, then here we will draw some adder, and this here I am taking z minus 1 as the delay. Okay, so this is our output basically yn. So yn output is depending upon the yn output is depending upon, first of all it is depending upon the input we are supplying, that is the xn. Then it is depending upon the output, this feedback also. So this feedback is the plus a y n minus 1. This is the z minus 1. This is basically a delay system. Okay, this box is showing the delay. Okay, delay of one sample. Means here I am giving the yn input here. So what is the output here? It is the y n minus 1. This from here we are getting y n minus 1 and a constant a is getting multiplied. So recursive system output is the y n is equal to x n plus a y n minus 1. So this is the output of the recursive system. Okay. So this is about the like recursive system and the non-recursive system we have discussed. So now I will explain you the LTI equation for the non-recursive system for the recursive system. So the topic is the LTI system characterized by constant option difference equation. LTI system characterized by constant coefficient difference equation. To drive this equation, I am using the recursive system. Okay, which system I am using? I am using the recursive system. Okay, we are having a two kind of system. First one a recursive system and the non-recursive system. Now I am using the recursive system. We are having y n is equal to x n plus a y n minus 1. Okay. Now I will drive the LTI system characterized by constant coefficient difference equation from this recursive system. First of all, I will put the n is equal to 0 in this first equation. I am getting the y0 is equal to x0 plus a y minus 1. Okay, I am getting this equation. Now I am put n is equal to 1 in equation first. I am getting y1 is equal to x1 plus a y0. Okay, so instead of writing this y0, I am putting this y0 value. It is the ax0 plus a square y minus 1. Okay, so I am put n is equal to 2. I will write down y2 is equal to x2 plus a y minus 1. So instead of the writing the like sorry, here it is the 1. Instead of writing this y1, I will put this value here. I am putting a x1 plus a square x0 plus a cube y minus 1. We are having these values. Okay, so now if you will see these equation, okay, if you will see these three equations, from these three equations, like first one is the x0 plus a y1 x1 a x0 a square y minus 1 x2 plus a x. I will write one generalized equation, that is the yn is equal to a n plus 1 y minus 1. Okay, plus summation k is equal to 0 to n a k x n minus k. So instead of writing these from these three equation, I am writing this generalized equation. This is the equation for LTI system for the like a LTI system for the recursive system, or this is also called the linear constant coefficient difference equation. Okay, so in the last in the signal and system we have done the numerical of this topic also we have applied find the homogeneous solution. We have find out the like a particular solution of this linear constant coefficient difference equation. So this is the very important linear constant coefficient difference equation. We have find out the solution of these equation. We have using this equation for the designing of digital filter or the designing of the difference equations. So this is the equation.